All right, welcome to section 6.5. We're almost done with the chapter here. This is a section on logarithm properties. And what we're going to learn in this section is we're going to use the properties of logs to evaluate logs, so to get answers. We're going to use the properties of logs to expand or condense log functions. So expanding means make bigger, condense means make smaller. And this all goes back to these properties. There's three of them. And then we're going to use the change of base formula to evaluate logs. So this is a very nice, you will really like this one. You'll probably be a little angry that I didn't show it to you sooner, but you'll definitely like this third bullet here. Okay, once again, sorry for my really bad jokes on the right here. All right, so there are three log properties that we need to talk about. Okay, so the first one is called the product property. Okay, because product meaning multiply. Okay, so this is what the property says. That if you have a log, okay, if you have a log base b, and then you have two things being multiplied together, you can break them up into individual pieces. You can take log base b of the first number being multiplied, and you can add that to log base b of the second number multiplied. And remember, all these properties can go both directions. They can be transformed to both properties. So let's see, let's create an example here. So let's say we have log base b of 3x. Okay, we can separate those. You can say log base b of 3 plus log base b of the x. Okay, and you could also go back the other way. If you had this on the right with the plus, you could turn it into a multiplication. Okay, the second property is the quotient property, quotient meaning divide. Okay, and so it says if you have log base b of m divided by n, you can separate them with a minus sign. So you take log of the top, which is m, minus log of the bottom, which is n. So for instance, if we have log base 3 of 3 over x, okay, we can set that equal to log base b of the top, which is 3, minus log base b of n, which in our case is x. Okay, so that's how you separate the quotient property. And then the last property of all of these is this third one here, and it's called the power property. Okay, so it says if you have some log and then some exponent, okay, so m to the n power, the property says you can take this exponent and move it to the front and multiply them. So hence n times log base b of n. So let's say we have log base b of 3 to the x power. This x can go to the front, so you could rewrite it x log base b of 3. Okay, so you can the exponent goes to the front. Okay, so what we're going to do in the next couple examples is we're going to use these three properties to help us through some examples. Okay, this first one, it says evaluate the given log function. So come up with an answer is what that's saying. And they're giving us two pieces of information. They're giving us that log base 2 of 3 is 1.585, and they're also giving us that log base 2 of 7 is 2.807. Okay, so then what we're going to do is we're going to look at the examples they give us and somehow use this information at the top to come up with our answer. Okay, so if we notice part A, okay, it says log base 2 of 3 divided by 7. So we're going to use the quotient property. You take log base the top minus log base 2 of the bottom, which is 7. Okay, so all I did was follow the quotient property. It says if you have something over something, you take log of the top and you minus log of the bottom. All right, so now we know the answers to these. If you notice, log base 2 of 3 is right here, and log base 2 of 7 is right here. So I'm going to take 1.585, and I'm going to subtract 2.807. And that should give me my answer. So I'm going to go to my calculator. I'm going to do 1.585 minus 2.807, and it will give me an answer of negative 1.22. Negative 1.22. So this whole thing is equal to negative 1.22. So we evaluated this log using our properties. All right, now let's look at the second one. All right, so how do we somehow come up with 21 using 7 and 3? Hopefully you see that 3 times 7 is 21. So I'm going to rewrite this log base 2 of 3 times 7. Okay, notice that this is multiplying, so I'm going to go back and I'm going to use my product property. which says if you have two things multiplied, you add them together. Okay, so m plus n. All right, so I'm going to do log base 2 of 3 plus log base 2 of my right number, which is 7. And remember, once again, we know what these two values are equal to. So I'm just going to plug them in and add. So I have 1.585 plus 2.807. And what does my calculator tell me for that? So the same thing, 1.585 plus 2.807 is equal to 4.392. So 4.392. Oops. And there's our answer to that one. Okay, so those two are done. Okay, last but not least, we have this problem right here. It says log base 2 of 49. Okay, how do I get 49 from a 3 and a 7? Okay, I could do this one of two ways. If I notice I have 7, I could do 7 squared. Okay, so I could rewrite this log base 2 of 7 squared. And now I'm going to follow the product property because I have a power property. So what does a power property say? It says if I have an exponent, I take it to the front, and then I just multiply the two together. So down here at the bottom, I'm going to take this 2, I'm going to move it to the front. So now I'm going to have 2 times log base 2 of 7. Okay, so I have 2 times, what is log base 2 of 7 equal to? Well, log base 2 of 7 is right here. Remember, it's this one that we just did. Log base 2 of 7 is 2.807. So I'm going to plug in 2.807. And now I just do my multiplying. So 2 times 2.807, 2 times 2.807 is equal to 5.614. 5.614. So this is equal to 5.614. Just make sure I double check. Yep, 5.614. All right, and there's my 3 answers. Okay, so those are a little bit more difficult, but how do we get what we're looking for out of the 2 pieces of information that they give us is what we're trying to do there. All right, now we're going to use our log properties to expand. Okay, hopefully you know that expand means make bigger. Okay, so this is how we do this. All right, so let's think about what we have here. Oops, definitely don't want to use the highlighter anymore. All right, let's see what we have here. Get rid of that, sorry. All right, so let's look at the top. Okay, on the top here we have, this is 5 times x to the 7th. So I'm going to separate the times with a plus. So I have ln of 5 plus ln of x to the 7th. And then now notice I have a division bar. What is the sign for division? Well, that's minus. That's the quotient property. So now I'm going to use the minus, and then what's on the bottom? Y, so ln of y. Okay, so we're almost fully expanded. The only other thing I can use to make this bigger is that, remember, exponents always go to the front of the log. So I have ln of 5 plus 7 ln of x minus ln of y. And now I've fully expanded that original problem using my properties. All right, so let's try this third one over, or the second one over here. All right, so I have log base b. What's happening here? This, hopefully you see that this is a multiplying. So what do we do with multiplying? We add them together. So I have log base b of 3 plus log base b of x to the 4th. And hopefully you don't forget that the 4 goes to the front. So my final answer is log base b of 3 plus 4 log base b of x. And then there we have it. There is our 2 fully expanded equations. All right, so now we're going to reverse the process. Instead of expanding, we are going to condense, or make smaller. Okay, so if you notice, these are fully expanded. We're now going to make them smaller. So notice all of these are log base 10. So I'm going to write my log right away. When you condense, you only have 1 log in your answer. Okay. All right, so I have a plus, which really means multiply, and I have a subtraction, which really means divide. So I'm going to have a division bar. All right, so let's see what we have here. The first number on the top is 9, and it's going to be multiplied by, notice that this 3 has to go to the 2. Okay, so this 3 is the exponent of the 2. So I have times 2 to the 3rd power all over 3 which is on the bottom because it's minus 3. All right, and then what you need to do is you need to just do that math there. So I have log of 9 times 2 to the third is 8 all over 3. So log of 72 over 3. And then we'll see if this reduces. 72 divided by 3 is equal to 24. So my final condensed answer is log of 24. And notice that this is a lot more condensed than that original problem that they gave us. All right, so let's do the next one. Oh, I don't know why that keeps happening. All right. All right, so let's see what we have here. So we have 2, this should go to the 4. We have a 3, that should go to the 3, and then we have that 6 by itself. But we also have a plus sign there. Okay, so we have this plus. So plus means multiply, this minus means divide. So I'm going to put my 1 ln with my division bar. I have a 4 to the second power. I'm going to multiply that by 3 to the third power, and I'm going to divide by 6. All right, so let's see here. All right, so we have 4 squared. We have 4 squared, which is 16, times 3 to the third, which is 3 times 3 times 3, which is 27, all over 6. All right, so let's see here. Let's reduce first. We can reduce this first. 3 goes into 6 twice. 3 goes into 27 9 times. All right, and now I'm going to reduce again. 2 goes into 2 once. 2 goes into 16 8 times. And now all I have is an 8 times a 9 divided by 1. So 8 times 9. So notice 8 times 9 is 72. And on the bottom I just have 1. We really don't need to put that. We don't need to put divide by 1, so I'm going to get rid of that. So basically my final answer is ln of 72. So we condensed this big thing down to ln of 72, and all I did was use my log properties up from the first page. All right, the last thing is super easy. Okay, so remember, the calculator will solve, so the calculator does log base 10, and it will do ln, and don't forget that ln is log base e. So the calculator does that. There's a log button and an ln button. All right, well, what happens if it's not a log base 10 or a log base e? Well, way back in the day, mathematicians figured out we can use this change of base formula to figure out any single log that we want. Okay, so the change of base formula helps us. Okay, the change of base formula helps us solve all logs with all bases. And here's a simple little formula. All right, so if you have any log with any base, you can just transform it into log base 10 of a divided by log base 10 of the base, or you can do ln of the top of the a divided by ln of the base, which is c. All right, so that won't make any sense until we do an example. Okay, so right now it says use the change of base formula to solve the following log. Well, I cannot do log base 3 of 8 on my calculator, and I definitely do not know what 3 raised to what power is equal to 8. I don't know that answer, but the change of base formula will help me solve it. I can do log of the number next to the log, so which is 8, divide that by log of 3, or I can do ln of 8 divided by ln of 3, and that will give me my answer. All right, so let's see here. So now we're just going to use our calculator. Log of 8, close your parentheses, divided by log of 3. And now I can do any single log that they give us. Or I can do ln of 8 divided by ln of 3. And that should give us the same exact answer, which it does. So my answer is 1.89. So you can now do any log on your calculator pretty easily and pretty quickly. So don't be mad, but I wanted to wait till this section to do this because I wanted you to actually know how to solve a log before we went on to this. All right, so that's it. That's section 6.5, which is log properties, and I will see you tomorrow.